So it was interesting. I was teaching Chemistry 1 during the pandemic, and I had a video that was very old. It was one of the first video series I'd made after I did my original video series, which is Lewis structures. And it was interesting because this was a very old video. It was still being filmed on the iPad that I was given when I first started doing the recording, and it was still using, I think it was my first foray into Camtasia. So you're going to notice that this video looks radically different than the videos around it. It's because it was recorded at a much later date because a student finally found a mistake in the video. So in this video, we're going to talk about the concept of limiting reagents, and we're going to talk about one method of doing this, and this is what I consider the brute force method for figuring out the limiting reagents. So how do you know you have a limiting reagent problem? Because that's a good thing to know. There's no point in doing this analysis if there's not a need to do it. Well, a tip-off that you don't have a limiting reagent is if you see excess amount. So one thing is being run in excess of another. That tells you that the excess thing is not the limiting reagent. You're going to figure out yields based on the other thing. However, if you get a problem and you're given finite amounts of both compounds, this is usually a tip-off that this is a limiting reagent problem. So one of these compounds runs out first. And when it runs out, that's going to be when the reaction stops and you're not left with anything else. So how do you figure out the limiting reagent and the yield based on it? So to do this problem, we're going to do an example. And this example here is 42.1 grams of nitrogen and 8.15 grams of hydrogen. So we'll write that up on the board, 42.1 grams of N2 and 8.15 grams of hydrogen. And we're running this reaction of nitrogen plus hydrogen goes to ammonia, NH3. So in the brute force approach, what we're going to do is we're going to calculate the yield based off the nitrogen and the hydrogens both at the same time. And whoever gives us the smallest yield, that's the limiting reagent. So in order to do this, we're going to start with our mass of each one. And with all these problems, your first step has to be that you're going to go to moles, because you can't do anything in grams, you need to go to moles. The first step, divide that by the 28.1 or 28 grams of N2 for 1 mole of N2. And for the hydrogen, for every mole of H2, there's 2 grams of H2. Now, to figure out what we need to do next is we need to convert from moles of whatever we're working with to moles of ammonia. So we need to go from moles of N2 on the top to moles of NH3 on the top, and from moles of H2 to moles of NH3. Now, you notice that we're both going to finish on moles on the top, but we got a different moles in the bottom because we're coming from a different place. Here we're coming from nitrogen, here we're coming from hydrogen. So how do we figure out what this ratio is? Well, we just look at the reaction. So here we produce 2 moles of NH3 in the reaction. To figure out the moles for the other ones, we just look at what they are in the reaction. So here we don't have it written, but there is a 1 mole of N2, and here there are 3 moles of H2. So this conversion factor relies on the reaction stoichiometry, and it basically says that if we look at the reaction, we know that there is a 2-to-1 ratio between ammonia produced and nitrogen consumed, and a 2-to-3 ratio of moles of ammonia produced for every 3 moles of hydrogen consumed. From there, we just convert back to mass. So there are, for nitrogen, 17 grams of NH3 for 1 mole of NH3, and then 17 grams of NH3 for every mole of NH3. And if we work out the units here, grams of nitrogen disappear, moles of nitrogen disappear, moles of ammonia disappear. That gives us grams of ammonia. Grams of hydrogen disappear, moles of hydrogen disappear, moles of NH3 disappear, and we're left with grams of NH3. Now, when you do this, and this was the mistake I made in the previous video, which is super annoying because it was at the very end. Based on our nitrogen, we will produce 51.1 grams of ammonia. And based on our hydrogen, we will produce 46.1.2 grams of H2. So, based on the starting amounts we have of each, converting to moles, using the reaction stoichiometry to convert to moles of product, and then just converting from moles of product to grams of product, we get that we produce 51.1 grams of ammonia from nitrogen, and it's 46.2 grams of ammonia from the 8.1 grams of hydrogen. Because we produce less ammonia with the hydrogen here is our limiting reagent, and that's what we're going to carry forward to do most of our calculations from here on out. Now, next video, I'm going to talk a lot more about a different technique. There are other ways to figuring out limiting reagents, but this is the one I think students find the most intuitive, though honestly, it's not the most versatile. And that's why we have more than one way of doing this.